Hi and welcome. So let's solve this question. Find the length of the largest subarray with sum equals to 0. What is this question? Let the array be 3, minus 3, 4, 5, minus 6, 20 and 30. So we need to find the length of the largest subarray with sum equals to 0. What is the meaning of sum here is nothing but if we see the subarray from index 0 to 0. In this the sum is nothing but 3, it is not 0. So if we see the subarray from 0 to 1, so 3 minus 3 will give me a 0. So 3 minus 3, that is the subarray from 0 to 1, is one of the subarrays with sum equals to 0. Okay, it may not be the largest, it may be the largest, but it is a subarray with sum equals to 0. Okay, similarly we can check for 02, 03, 04 and so on. Okay, this subarray right here is the largest subarray, that is from 1, 2, 3, 4, 1, 4. Okay, so 1, 4 will give me a sum of 0, 9 minus 9, fine. So in this particular case, and the length is nothing but 4. Okay, so this is the largest subarray with sum equals to 0 in this particular question. Fine. So just think about the brute force approach in this particular question. I have already written it. This is nothing but the brute force approach. What we are going to do is using a nested loop. Fine. The outer loop will simply have the starting index of the subarray and the inner loop will just traverse through the entire remaining array. Fine. So if I equals to 0, j will move from 1 to n minus 1. Fine. So in this particular case we'll have two variables. One variable is sum, another variable is, let's say, max length. Okay, so here just do this. Sum equals to nothing but the 0, that is array of 0 plus array of j. Now if this particular sum is 0, so we need to check our max length. Fine. If it is not 0, then simply we have to move forward. For example, this sum will be 0 in the case of 0, 1, as we have already seen. So max length will be checked. So if max length is less than j minus I plus 1. So what is j minus I plus 1? It gives nothing but the number of elements present between a range. So 1 minus 0 plus 1 is 2. So there are 2 elements. So if it is less than j minus I plus 1, so max length will become j minus I plus 1. Okay, and if it is greater than, we will not do anything. So similarly now max length will become 2 in this case. Next zero subarray is nothing but 1, 2, 3, 4, that is from 1, 4 when I value is 1 and j value is 4. So in that particular case j minus I plus 1 will become 4, max length is 2, so 2 is less than 4, therefore this will be updated. Okay, so the max length will become 4. No other subarray is forming this particular case. Okay, that is nothing but the sum with 0. Only these two subarrays are the arrays that are having the sum as 0. So we need to choose from the maximum length and that's it. So obviously this approach has the time complexity of order of n square. Fine. So we need to think of something else now. Okay, so this is a very straightforward approach. Now let's think of a different approach. We will be using a hash map, and using that, by increasing the space complexity to order of n, how we are going to decrease the time complexity to order of n from order of n square. Fine. So let's see this approach now. So let's see another approach now. Now in this particular approach, what we are going to use is nothing but the concept of prefixes. Fine. So concept of prefix sum. So let's see. So the sum is currently 3. When the element is 0, the sum is 3. So our key will become the sum. Okay, and where the sum has occurred will become our value. So 3 and 0. So this is key in our hash map and this is value. Now next, when the array element is nothing but 1, so 3 minus 3 will become 0. Okay, as soon as the sum will become 0, we will calculate our max length. Fine. So now since the max length was 0 currently, so therefore we can directly calculate it as the index plus 1. Okay, so it will become nothing but 2. Is 0 present? No, it is not present, and it came at an index of 1. Fine. Then sum will become 4. So 4 is not there, so nothing but 4 will become 2. Then sum will become 5 plus 4, 9. So it is not there, so 9 at the index of 3. Now 9 minus 6 will become 3. So 3 is already present in the array. So we came back to 3. What is the meaning of this? Just think about this. So what is the meaning that 3 came again? See this. So we have 3, minus 3, 4, 5 and minus 6. Fine. Now prefix of 0 is nothing but 3, and prefix of 0, 1, 2, 3, 4 is also 3. How? Just add it out. So we just added it out, correct? 3 minus 3 is 0, 9 minus 6 is 3. So both of these indexes, that is 0 and 4, have a prefix of 3. Okay, now if I subtract it, that is nothing but prefix of 4 minus prefix of 3, it will simply become prefix of 0, it will simply become what? 0. 3 minus 3 is 0. Fine. So this is what we were looking for. That means nothing but the array of what was the first element, that is I. So I plus 1 till array of j. Okay, if we sum all these elements, the answer is 0. Okay, because we are already nothing but adding all the elements, correct? And when at this position we came at 3 and 3 was already present there, so if we subtract it, the sum will be 0. That means all the elements present after this element till this element have the same sum, as this particular element. So the subtraction is becoming 0 and nothing else, as simple as that. So we were looking for this sum again, so we found it. That means at a index 0 the sum was 3, at the index 4 the sum was 3. So what is the maximum length now? 4 minus 0. So the max length will now become simply 4, if it is greater than the current max length. Fine. And we are simply now moving forward. So now it will become 9 and it will be 3 and it will be here. Fine. Now after this, now simply at 20 it will become 23, which is at 5, and the 30 no use now, 53, and it becomes 6. Okay, so the max length updated now will be 4. So what concept we use? We use the concept of prefix sum from a particular index now from a particular index till a particular index. Now both the sums are same, and if we subtract the prefix sum, we get the value of 0. That means the element present at I plus 1 to j has a sum as 0. Okay, as simple as that. Now how we are going to implement this? So it's very easy to implement. The sum will become nothing but our key, and the value will, and the index will become our value. Okay, we can switch it also. Fine, but it is easier to implement this way. Sum is this, and the index is nothing but our value this time. Fine. So max length is directly calculated. It is very easy. This we can directly store in our hash map. This is also easy. If the sum is repeated again, that means we already have a value of that particular sum in our hash map. Then what we are going to do? We are going to select the maximum between the current max length, okay, and the index, the current index minus the already present value. Fine, whichever is maximum. So in this case, the current was 2 and the I minus value was 4. So we chose the 4 one. Fine, so max length will become 4. Finally, we will return our max length. Okay, so let's now see the implementation of this particular concept. Hi, and let's see the implementation now. So we are taking all the regular inputs, test cases, array, and passing in our maximum subarray with sum0 function. Here we are taking a hash map. Okay, sum equals to 0, maximum length currently equals to 0. Then add the current element to the sum. We are adding the current element to the sum. If the sum is 0, then we are calculating our max length. If the sum is already present in our hash map, then I have told you we need to check the maximum between the current max length and our subtraction of our indexes I minus, because in our hash map now value is an index, so I minus that particular index. If the sum is not present in our hash map, then we need to put it into our hash map using the put function. This one if condition is also there. This if condition is to handle the case when a particular element is itself 0. Okay, so in that particular case the maximum length is 1 for that particular subarray. Okay, if it was 0. Let me tell you with an example. So in this particular case, as you can see, subarray of index 1 comma 1, okay, is nothing but 0, and there is no other subarray with sum 0. Fine, so therefore this becomes our only possible maximum length subarray, which length is nothing but 1, just one particular element. And here we already seen this answer is 4. Fine, so this was the direct implementation. As explained, it is pretty straightforward implementation. Okay, implementation wise it is nothing, just you have to think of the logic. Fine, thank you.